Welcome to day 6 of our Matrices unit. We'll be reviewing for the quiz that you'll be taking this week. So today we'll be working through the entire packet that you have in front of you that you should print it out from MCPS portal. So for number 1, find the value of x and y to make the equation a true statement. Now when I'm looking at this, there's only one variable here, and that's the variable x. And as I'm looking at this, remember, when we're scaling matrices, that's what's going on here, is it's a constant outside multiplied into the matrix. I can look at 3 times 4, and I get 12. I can look at 3, and negative 6 gives me negative 18. 3 times x equals negative 15. And then divide both sides by 3, and x is going to equal negative 5. And just notice there's one other variable over here. Because 3 times negative 9 equals y. So y is going to equal negative 27. Performing the indicated operation. So as we're doing this, remember that when we're multiplying, here's rows times columns. So I do this row, and about rows times columns. So I'm going to be doing that with my rows. I'm going to be doing this with my columns. And that's going to be, I want to double check to make sure I can do this. 2 by 2 and 2 by 2. Yep, those match up. And then the outside numbers a 2 and a 2 lets me know that my answer is also going to be a 2 by 2 matrix. Okay, so as I'm setting this up, I know that it's going to be 4 times 1. I'm going to say 4 times 1 plus 4 and negative 5. We got into a little bit of a pattern last time. 4 times 1, negative 5 times 0. And if you remember that pattern here, if I just said 2 by 2 and 2 by 2, I'm going to have 2 sets of 2. These numbers right here tell me how many sets of 2 I'm going to be multiplying and adding together. I have 2 sets. Just for space, I'm just going to lock these in place so I can then move what I've already done. Okay, so remember, down here it's going to be row 2, column 1, because I'm in the first column of this new matrix that I have. So first column, second row. So it's always rows by column. So it's 1 and negative 2. Notice my column 1 is still 1 and then 0. I'm going to have column or row 1, column 2 over here. So row 1 is going to be 4 and negative 5. Notice all the red numbers on the top row are the same: 4, negative 5, 4, negative 5. Then over here it's going to be 0, 1, 0, and then 1. And those are also going to be 0 and 1 since it's in the same column. And then 1 and negative 2. We get some more practice with that multiplication as well. Now, every time that I multiply, I generally have one more step of simplifying, but if I have a bunch of zeros, let's say just a little bit of time, and then we can do that simple multiplication all on our own. 4 times 1 is 4. 1 times 1 is 1. Negative 5 times 1 is negative 5. Negative 2 times 1 is negative 2. And let's see what happens. Wow. That's going to be the same matrix that we started off with. Because I multiplied by this right here, 1, 0, 0, 1. Notice that it's a diagonal, a downward sloping diagonal of 1 to everything else is a 0. That's called an identity matrix. This one right here, as I do the subtraction, it's going to be 5 subtract 3. So it's upper left, subtract upper left. 5 subtract 3 is 2. 7 subtract 5 is 2. Negative 6 subtract a negative 1, give me negative 5. Remember, when you're subtracting, a negative becomes positive. 1 subtract 8 is a negative 7. This part right here is going to require some scale the matrices. So I have a 4 scale into that first matrix. So it's going to be 12. It's going to be 20, -8, and 4. Subtract it. I'm just going to scale it by 3. Be -6. So notice that I'm actually, there's two different ways. I could leave that as a negative, or if I distribute the -3, I can turn that into addition. So that'll be a little bit easier. So -3 times -2, +6. -3 times -1 is +3. -3 times 1 is -3. -3 times 8 is -24. This means I kind of bring the negative on the inside of it. The 12 plus 6 is 18. -8 plus -3 is -11. 20 plus 3 is 23. 4 plus -24 is negative. So we've done some addition. We've done some, more complex scaling of matrices. Did some subtraction, some multiplication. Now we're going to go into that another component that we touched on. It was one of the more often missed for my students who did not complete on Delta Math. So I'm just, we want to take a little extra time on this right here. So it says find, and it has a matrix in this to the -1. Remember, this right here is just a fancy way of saying find inverse. Okay. And I've written this equation down over here because Miss Schuler would have gone over this, I believe it on day 2. Okay. So when we're finding this inverse, we need to find is 1 over the determinant, this AD subtract BC. The vocab word for that is determinant. So I'm going to say my A value is 2, my D value is 4, so it's going to be 2 times 4, subtract B times C. So B is 1, times C is that. So I'm going to get 8 subtract 7, which equals 1. That's very nice because when I set this up, when we set it up, it's going to become 1 over 1. I'm just going to leave in black the things that aren't changing. This right here, the determinant we found was in red, so I'll leave that in red. Now notice this is a little bit different. So I have the A value and the D value switching spots. So this 2 goes down here, this 4 goes up here. They change spots. B and C don't change spots, but they do change signs. So something happens to every single one of those terms. After that, all we're doing is we're multiplying through. Now this one's nice because just 1 divided by 1 is 1, so I'm multiplying everything by 1, which makes it really easy to do. And some of them might have had fractions. In that case, if this was instead of a 1, if it was, let's say, 1 over 11, this would be 4 over 11. We could do that as our fraction for Delta Math. So just want to put that out there. For numbers 4 and 5, find the value of the missing value. It could be worked on a little bit, but the variable to make the equation true. Now this is different. Questions 4 and 5 are different from what we did on the warm-up. On the warm-up, we were multiplying, but it was by a scalar. Now we have to remember rows by columns. We did some of this together on day 4. All right, so I'm going to multiply it. This is where my x is. And so since I circled the bottom row, I have to circle the bottom row of my solution matrix. And over here, it doesn't matter which one which column I want to circle. It's going to give me 74 and -78. I kind of like working with 9 instead of a -7, so that's perfectly fine. So I'm going to set it up. Remember, I'm multiplying these together. Now you could absolutely multiply the entire matrix together if you really wanted to, but that's just going to be a lot more work. So if you kind of see a shortcut, it saves you a lot of time. We have a -8. -8 is times 2. That'll be x times 9. Remember, it's -8 times 2, x times 9. That's going to equal, notice this is second row, first column, second row, first column, they overlap on 74. So I'm going to get negative 16 plus 9x equals 74. I add 16 to both sides, so I get 9x equals 90. X is going to equal. And just a reminder, the better notes you take now, the easier it is to reference them when you're taking your quiz this week. And every week, since they are open notes, we are taking that into account as we assign them. So it is not cheating. We know that you have open notes. So please use those as a reference. Once again, we have an X value. Now in this case, once again, remember, in the first matrix, it's always going to be by rows, and the second one is always going to be by columns. So I'm going to say, I circled the second row, so I'm going to circle the second row again. Now remember, it doesn't matter which column we used. I used the first column last time, so I'm going to use this second column just so you see something a little bit different. I'm circling that second column. Notice they overlap on negative 36. I'm going to set this up. Black, just to set off that color. No, red is me. I put it first, and my column is 1 and 8. Notice it's always a row times a column, a row times a column. So multiply that out, we get x, subtract 40, with negative 56. I add 40 to both sides, x is going to equal 4. Question 8. Find the value of x where it does not have an inverse. Okay. We're just going to go through all the problems this time. Now remember, it does not have an inverse. This right here lets us know how to find an inverse, but if it does not have an inverse, remember, I can multiply this matrix by 1. If this was a 1, I could go multiply it by 1 or a negative 1. There's only one thing I can't multiply it by, and that's going to be when AD subtract BC equals 0. Because 1 divided by 0, we can't do that. That is undefined, and I can't multiply by something that's undefined. So that's the thing that we're looking for. So I want to set it up so that the A value times the D value, give me 12, negative 2, subtract 8x is going to equal to 0. So I set it equal to 0, I start solving. So I get negative 24, subtract 8x equals 0. Negative 24 equals 8x. Divide both sides by 8. And you get x equals negative 3. So if the x value, if we substituted in a negative 3 for that x value, we could not find an inverse. Notice it's not asking me to find an inverse that does not exist. It's saying find the value of x so that the matrix does not have an inverse, so that it does not exist. And that happens when the determinant equals 0. AD subtract BC. But finding the inverse. It's a little bit more practice from what we did earlier on. So I'm just going to say AD subtract BC. I'm going to remind myself. So that's going to be 12 times 5 is 60. Subtract 3 times 20 is 60 is 0. So wait a second, we just talked about this. The determinant equals 0, which means I'm going to have 1 over 0. And just for practice, I'm going to switch the A and the D values. I'm going to make the B and the C values negative. But remember, because I'm dividing by a 0, that's red. Inverse does not exist. Over here, I'm going to do my A value and my D value. Subtract BC. My AD is 2 times 5, which is 10. Here, 3 times 1 is 3. So I now have 10 subtract 3, which equals 7. Okay, so I'm going to set this up. 1 over 7 is 1 over the determinant. I'm switching my A and my D values, so those switch places. These switch signs. And I'm going to multiply it through. 1/7 times 5 is 5 sevenths. -1 times 1/7 is -1 seventh. 1/7 times -3 is -3 sevenths. 1/7 times 2 is 2 sevenths. So nothing too bad about that. Okay, I'm going to make these stand out a little bit more. All right, number 12. Remember, to add or subtract, they have to have the same dimension. So this is a 1 row, 1 by 2. Now, when we're multiplying, we check these numbers right here, but when we're adding or subtracting, they have to be the exact same, 1 by 2 and a 1 by 2. That works, which means I'm going to add this 1. I'm adding here 1 plus -3, I mean -2. 4 plus 5 is 9. As I'm looking at this, I have 2 rows, 3 columns, 2 rows. So 1 row, 2 rows, 3 columns, 1, 2, 3. So I'm just double checking those dimensions. And right away, when I'm adding or subtracting, I know that if it's a 2 by 3 and a 2 by 3, it has to be a 2 by 3 for the answer. If it's a 1 by 2 and a 1 by 2, the answer has to be a 1 by 2. Addition and subtraction will always result in a matrix of the same dimensions. I'm going to add this up. 2 plus 11 is 13. 3 plus 9 is 12. -5, that middle one. I'm just going to do these middle ones next. -5 plus -4 is -9. 7 plus -3 is 4. 0 plus 2 is 2. -1 plus 8 is 7. Just as a reminder, as I'm doing each of these problems, since it is a review, if you want to pause before I start a problem and then work it through and then double check your answer, that is great. So remember, rows by columns. So first thing I have to do, and double check the dimensions, 2 by 2 and a 2 by 2. That works out well right there. And then this 2, let's rename. My switch matrix will be a 2 by 2. I think I've been using green, so I'm going to go back and change that. So we got rows by columns. Rows. Columns. So just a reminder, we know that they match up on a 2 by 2. So we're going to actually know that it's going to be this number right here. Since it's the same, we know that's telling me there's going to be 2 sets of numbers that are multiplied and added together. Now, a common mistake for students is getting the determinant confused with multiplying matrices. And I understand that because it's two things you're multiplying together instead of adding or subtracting for the determinant. Know that when we're multiplying, okay, this will always be additional. I'm filling in that top row is 2 and 0, 2 and 0. So just systematizing a little bit. That second row is going to be only 0s and 2s, 0s and 2s. First column is 1, and then 9, 1, and then 9. And just make sure that that first upper left box is first row, first column. It needs to get a 1 and a 9 in that one. It's not 1 and 9 right here. That would be a mistake. But sometimes slowing down can be helpful. And then -6. And 2. And 6. And 2. It looks like in each one of these, there's something that cancels out and is a 0, so I'm going to cross those off so I don't have to do that multiplication. And that makes our job a little bit easier. 2 times 1 is 2. 2 times 9 is 18. 2 times -6 is -12. And 2 times 2 is 4. You might notice that this would look kind of like an identity matrix, but instead of ones, it was twos, which means instead of multiplying by 1, you're effectively multiplying everything by 2. Notice, everything doubles. 1 and -6 becomes 2 and -12. 9 and 2 becomes 18 and 4. Once again, you can pause this and give yourself a little bit of time to work on it. Setting it up as I did it last time. So there's square matrices, so it's a little bit easier to tell if they do work out because they're the same dimensions, but 2 by 2. These outside numbers tell me this will be a 2 by 2 right here. So you've been wondering where I get that from. Actually, now I'll start filling this in. 3 and 4. 3 and 4. 1, 6. 1, 6. Column 1 and -2. 1 and -2. Column 2, notice this is all of column 2, it's going to be 0 and 5. 0 and 5. Then multiply this out. Nothing cancels out and equals 0 here, so I'm going to take an extra step and I'm going to simplify each one. 3 plus -4 times -2 is 8. 1 times 1 is 1. 6 times -2 is, I'm adding -12, so I'm just subtracting 12. 3 times 0, well, looks like we have a couple of zeros, so that makes our lives a little bit easier. -4 times 5 is -20, and 6 times 5 is 30. And this right here is going to be 11, -11, -20, and 30. And if you're working, if you want to ever double check any of your answers, just know that the answers are on the back, the very back of this. Okay, so some multiplying of things that are not square matrices. So our first step we should always do, if it's a 2 by 2 and a 2 by 2, you're looking at it, you kind of know already what it's going to look like. For this one though, we want to make sure that we don't do extra work. It's 1 row by 2 columns. This is 2 rows by 2 columns. Those numbers do match up. So these outside numbers tell me the dimension. Just give me a 1 by 2. It's going to kind of look like that first matrix when we're done with it. What we have here is, the question is, do we put it to the underneath or to the right for this next section? Remember, it's a 1 by 2. So it's 1 row, 2 columns. So this is row 1. So I'm not moving off that row at all. Okay, row 1, and I like doing this just so that I don't get confused. I'll fill it in row 1, 1, 4, and a 1 and a 4. Column 1, -4, 6. And then column 2, 3, and 2. After doing the 2 by 2s, it does feel like you're supposed to be adding more there. Remember, the outside will always tell you the dimensions of the solution matrix. As I multiply this together, I get -1 times, 1 times a -4 is a -4 plus 24. And I have 1 times 3, which is 3. 4 times 2 is 8. The but that can be a positive 20, 11. That right there is our answer. But even if they're not square matrices, they can be multiplied together, but you have to do that check first. The question 17, a lot easier than what we had seen before. It's literally just scaling right here. So we're just showing that negative 2 to everything. So the answer is going to be negative 22, positive 8. Negative 2 times 2 is negative 4. Negative 2 times 9 is negative 18. Negative 2 times negative 3 is negative times negative is positive. Negative 2 times 8 is negative 16. There we go. For 18, this is where we get something a little bit larger. So let's try that out. 2 rows by 3 columns. This is 3 columns by 2 rows. Those numbers match up. And note, in a sense, the solution matrix is going to be smaller than either one of these. We get 2 by 2. I mentioned this because it's going to help us set up what this next part's going to look like, because it's going to look like this is a 3 right here, which means I'm going to have 3 sets that are multiplying together. So 1 set, 2 sets, 3 sets. 1 set, 2 set, 3 sets. That right there is 2 rows, 1 column. So I need to create another column. 1, 2, 1, 2. There we go. And just as a reminder, as I'm looking at this, I'm going to erase this part next, but I now have 2 rows and 2 columns. I'm just going to fill that in. 2, negative 5, and 0. Right, put our number there. Negative 5. 0 is going to be multiplied to 1, 4, and 6. Now right away I see that it's being multiplied by 0, so I'm going to cancel that part off right there. Okay, for the next row that I have, 3, 7, negative 1. Okay, this is row 2, 3, 7, negative 1. That's going to be multiplied again. This is still in column 1, so it's 1, 4, and 6. 1, 4, and 6. As I look at this, once again over here, it's the top row. So I'm using 2, negative 5, and 0. Multiplied to this second column right here, which is 0, negative 3, negative 2. I notice there's a couple of zeros there. That's going to cancel out. That's going to cancel out, making my life a little bit easier. And this bottom row is 3, 7, negative 1. Once again, still column 2 because this is first column, second column. 0, negative 3, negative 2. We'll multiply each of these out. 2 times 1 is 2. Subtract 20 plus 0 is 3. That's 28. Subtract 6. We here negative 3 times negative 5 is going to be positive 15. And I like leaving this enough space so I don't think that I'm supposed to add these numbers here together. These are separate elements. So 3 times 0. Take it out. We're left with negative 21. Negative times negative is positive, so plus 2. So 2 subtract 20 is negative 18. 3 plus 20 is 31. Subtract 6 is 25. With 15, and we have negative 13. Given matrix A is a 2 by 2 matrix and has an inverse, matrix B is a 3 by 3 matrix with an inverse. It's asking us to find each of these things. Now, the operation occurring between them is multiplication. Remember that from what we've talked about before is a matrix times itself, matrix times its inverse is always going to equal the identity matrix. We covered that on day 3 or day 4. So when I have this right here, if I know that it's some number times its inverse, think about 8 and 1/8 being multiplicative inverses equals 1. Or let's say that you have 3/4 times its inverse. First multiplicative inverse is going to be 4/3. 3 times 4 is 12. 4 times 3 is 12. It equals 1. Now remember, when it comes to matrices, you're not going to get an answer of just 1, but you can get an identity matrix. Now it tells us that A is a 2 by 2 matrix, so when I multiply them, the downward sloping diagonal, the transversal diagonal, is going to be 1, everything else is zeros. When it tells us that B is a 3 by 3 matrix, we've seen it once before as kind of an example. Let's go 3 by 3 matrix. We can go 1, 0, 0. It's 3 columns, and then the downward diagonal, this is all ones. So that is what it's going to look like. These are identity matrices. This is a 2 by 2 identity matrix. This over here is a 3 by 3 identity matrix. Where we're at. And notice that for each of them, I have also switched up the order. A matrix times its inverse is the identity matrix. The inverse times its matrix is also an identity matrix. It's still the same thing. It doesn't matter the order in which to multiply them. Remember, that's not true for all matrices. If we're going to go back and multiply any of these other matrices up here, if we switch the order of them, my answer, my solution matrix would be different, or would likely be different. All right, so we're solving for x. I'm adding here. It's bottom right. Now notice we've just done a lot of multiplication where we might want to, we're thinking it's rows times columns, but we're adding here. So always look for what operation you're doing. So it's going to be x plus 9 equals 18. And subtract 9 from both sides, you get x equals 9. Here we have some scaling that we have to do. Notice my x is still in the bottom right, so it's going to be 2 times x, it's going to be 2x, plus 2 times, we're also doing bottom right here, plus 2 times 4, which is that's simple enough. It's going to equal the bottom right because we're adding or subtracting. Subtract 8 from both sides, 2x equals, and x is going to equal 5. 22. Notice in this case, instead of addition or subtraction, we're now multiplying again. So when I'm doing this, rows times column. Now, it doesn't matter which one. So I'm looking at like 4, -9, or do I want it to equal -24 or 40? It doesn't matter which. I kind of like 40 a little bit better, so I'm just going to, all right, I'm choosing the second column. Remember, we don't have to multiply it all out. You can, but it's going to be more work. There's going to be 2 sets of 2 multiplied together that equal 40 where they overlap. My rows are 0 and x. My column elements are -9 and 5. So 0 times -9 is 0. So I just get x, 5x equals 40 divided by the sides by 5. We get x equals 8. Solution for x. Again, same thing, but notice my x value is over here. It's not in a row, but it is in a column, so I have to use this column. I have to use this column right here. Now, it doesn't matter, remember, really which row I use. Now, I do have, if I choose this one right here, it has a 0 on it, which is actually quite nice. I just need to make sure that 0 doesn't multiply to the 2x. So it's 0 times 4, 8 times 2x. Perfect. So I'm going to set that up. And I'll show you that you can do either one of those as well. And if that's top row, that'll be 32. 0 times 8, 4, 2x. So 0 times 4 is going to cancel out. We're left with 8 times 2x, which is 16x equals 32. Divide by 16, you get x equals 2. Now I did say that we could also use that second row. I just want to show you what that would look like. We set it up the same way. We'll get the same answer. If you get different answers, it means that you made a mistake somewhere. Notice here though, we're using a different value on the end. So 32, what gave us this? Different here. We get 16, because it overlaps with the blue light, 16. So I have row 2, which is a 1 and a 3, multiplied to column 1, which I have to do because that's where my variable is, 4 and 2x. So 1 times 4 is 4, plus 6x equals 16. Subtract both sides by 4, we get 6x equals 12. Divide both sides by 6, and we get x equals 2. So notice the same answer, just a different way of getting there. This is the other lesson, the first lesson for this week is transforming matrices using matrix operations. Now it's asking us to translate right 5 units and down 3 units. Now we could go back to geometry and just say, all right, I'm going to take this point P and I'm going to translate it right 5 units, 1, 2, 3, 4, 5, and down 3 units, 1, 2, 3. I'll use a different color to make it stand out. Okay. You do that for each of these, 1, 2, 3, 4, 5, 1, 2, 3. That's not ultimately what they're wanting us to do. Okay. They're asking us to find, what I call it, R, C, P, S. This is not alphabetical, but you know, I'm just going from the upper right and kind of going around. Okay. I'm labeling these. This is my x values, these are my y values. So 1, 2, 3, 4, 5, 1, 2, 3. So R has an x value of -5 and a y value of 3. C is going to be -3, 3. P is at 0, -1, and S is at -5, 0. Move that over just to change. I'm going to be adding it to, this is my transformation matrix. I'm going to type that out here. That transformation matrix, notice I'm not going to be labeling A or an R, C, P, or S. This is just telling me what I'm doing. So what am I doing? My R values, I'm adding 5. So I have to have 4 5s there because I have 4 different points that I'm being moving, R, C, P, and S. So this -5 plus 5, -3 plus 5, 0 plus 5, -5 plus 5. And what am I doing to my Y values? All my Y values moving down 3 units. So -3, -3, -3, -3. When I add those together, that's what it's going to give me in my solution matrix. So it's going to give me this matrix right here. I'm going to go R prime, C prime, E prime, S prime. So we want to make sure some of that vocabulary there is our transformation matrix is the matrix that we use to transform RCPS into R prime, C prime, P prime, and S prime. So we have our transformed matrix. So as I'm adding this, -5 plus 5 is 0. 3 plus -3 is 0. Let's just double check that visually. So if I'm counting over 1, 2, 3, 4, 5, down 1, 2, 3, yeah, R prime is at the origin. Let's double check C prime. We said just doing it visually as if we were in geometry, it was 2, 0. Let's do that right now. We have -3 plus 5, we need 2. 3 plus -3 is 0. Yeah. That agrees. For P, we had 0 plus 5 is 5. -1 plus -3 is -4. Let's check. Go over 5, we go down 4. That does look like P prime. And for S, we have -5 plus 5, we get 0. 0 plus a -3 is -3. We're saying that we should go x value of 0, y value of 3 right there. -3. And that's prime. So from S, 1, 2, 3, 4, 5, down to 1, 2, 3. Yep, and we can connect those dots. Not as straight as I like it, but it's good enough for right now. And there's this last question that we have today. What matrix will allow you to translate RCPS right 3 units? Now, it's not asking us to write it all out as we had last time, but I'm going to just focus on the transformation. I'm going to write 3 units. I'm not going up, down, left, or right. Okay, so if I'm going to the right 3 units, you're thinking, is that affecting the x values or the y values? It's adding to the x value. So 1, 2, 3, that's going to be R prime. 1, 2, 3, that's going to be C prime. 1, 2, 3, P prime. So as you maybe do this visually, you're just thinking, all right, well, what am I doing? I'm moving all the x values to the right. So I'm adding 3 to all those. If you remember, the x value, y value. So it's 3, 3, 3, 3, because I have 4 points. And then what's happening here? I'm adding 0 to the y value because it's not moving up or down. So my answer here has to be B. And so as always, if you have any questions, please make sure that you are emailing your teacher or asking them over a Zoom session. If you have any particular questions, you can go back to any of the notes that you have as you reference and take that quiz this week. Good luck, and we'll see you next week.